Howdy. Today I'm going to be briefly discussing the Microsoft source code annotation language, otherwise known as SAL, and some of the use cases behind it, a few examples, and like why you should be actually using it. There isn't a lot of good information about this. The only real information I can find is MSDN's actual page, a YouTube video where they're discussing SAL 1.0 when we're actually on SAL 2.0 now, and another video from very, very early, probably mid 2000s, from a Microsoft presentation where they show the slides for the first intro slide, and then they never show the slides again, so you don't ever know what the guy's talking about. So what SAL basically does is let's say that you have some code that you wrote that you're going to be adding into a library or a DLL, and you want to make the intention of your code very, very clear. You could add comments. Comments are a good thing to add, but how do you also get, let's say, IntelliSense to figure out what's going on so that you can throw warnings or errors based on what's actually going on? Well, let's say that we have socket s is equal to socket from the WinSockets library, and I can just throw in null here. Now, if we compile this code, we're actually going to see something kind of neat. We should see a little error here, or a warning. There we go. S holds a value that must be examined, basically stating that S is a important value and it needs to be looked at and something needs to be done with it. Well, how does IntelliSense figure that out? It's not parsing the actual internal functioning of socket to figure out why it's important or looking at other use cases. It's actually using SAL, which is this little definition here, must inspect result. In addition, we also have these, which is stating the in parameters, and if we scroll down, we can see it's actually on almost all the functions. So in reads bytes of size len from address, in z, so a null terminated string from name, etc. So I have a little code example here. We have a destination buffer, 4096 bytes. We have a source buffer, 8192 bytes, and we have this function here, copy buff. Copy buff is simply just a parameter of mcopys that also deals with the SCH exception. So if we throw an invalid parameter, go up to here. So we just run this, make sure this works. We hit our little thing here. We got an invalid parameter. Oh no, function failed. Uh-oh, that's not good. Alrighty, so now, how do we make the intention of what this function should do correct? And how should we make this function basically work fine so that will not have an error? We can see when it's going to have an error. Well, we can use SAL annotation. So I have this I already wrote this out. Let me copy this over. So I've added some defines here. I have success, so we're determining what our success is. So if the function is successful, then the return is equal to true. We have the outright bytes all of source size. So we're writing to destination, or operand or parameter destination of size source. And we're also reading from source of source size. All right. So now if we come down, throw a little compile in here, and get IntelliSense to update. Come on there. There we go. Go to our warnings. Buffer overrun, we're writing to destination. Writable size is 4096 destination bytes, but 8192 bytes may be written. So define W all, warning error all or whatever, and you're going to be finding a warning here. You're going to be finding this bug before you're actually having to go through and debug your program, figure out why it's doing the SCH, what's going on, etc. Because you can just see from SAL annotation that, hey, this is going to cause a nice little issue here. Now, let's say that we have, let's write our own example. Let's say that we have a function dump characters, and we have a char pointer p buffer int in readable size. And now, if not p buffer, we can return. We don't care. Whatever. The in passes something. Damn, that sucks. For zero is less than readable size. Spelling errors. Oh my goodness gracious. Alright, so a simple function just dumps all the characters from my character buffer. Now let's add our SAL annotation to this. In reads bytes of in readable size and then just an in parameter, nothing special about this one, in readable size. Now what happens if we throw in destination size of destination? Well, it's going to compile fine. We're not going to get any errors. We are passing in a variable. It's working all right. Yeah, fine. I'll initialize your memory. Don't worry. So this is a valid call. But now, let's say that through some way we end up not actually passing in anything, so no pointer inside 0. Well, we're going to get a nice little SAL error for this once it updates here. Come on. Come on. My goodness gracious. Oh my dear lord, is this not going to update? Okay, you know what, I'll just reopen the solution. SAL tutorial. Let it parse. There we go. No. We should get a sound warning for this. Oh, I know why. That's why. There we go. Prime 1 could be 0. This does not adhere to the specification for function dump characters. So the reason we're getting this is because we're passing in a null pointer. It's like, hey, that's... Well, frankly, that's not valid. You need to have something coming in because you're going to be reading in readable bytes for it. But, of course, we actually are checking if we have anything. So we can add just a nice little optional tag here. And then now if we come down here, this little SAL warning is going to disappear. Now, I don't know when it's going to disappear because it seems like it's updating slow today, so I'm going to move on. Oh, there we go. But now, let's say we have a structure, right? And our test struct t, okay? So let's say that we change this function so that we can actually pass in something. So let's just get rid of destination size. Make this a nasty, not safe mem copy. Ugh. And then we'll just do this. There we go. All right, so let's define a new test structure. Buffer dot mn buffer size equal to, I don't know, 5. Perfect. And now let's copy buff. Mn buffer size. Let's do this. Alright, so now if we compile this, we're actually not going to get a warning here, but of course we want to actually detect that we're going to have some kind of error here. Well, the way we can do that is simply by adding SAL annotation to our actual struct definition. So what we can do is we can add field SAL annotations. So let's say that we have a field range of 0, 4096, and I believe I can do bytes here. I think that's valid. I guess not. Whatever, we'll just delete that. Shh, you didn't see that. And then this is going to be a field bytes. Field size bytes of in buffer size. So basically we're stating to IntelliSense that our field size can be of in buffer size. And then our range is between 0 and the max buffer size. So now we should get a SAL warning on this when I compile. Come on, SAL. You can do it. Let's go, SAL. Okay, I assure you that this will throw a SAL annotation error most of the time. It just appears like it doesn't want to really work today. Yeah, did that work? Why are you not? Oh, Wait, that's why that didn't work. Come on. Well, I assure you that if I were to reload IntelliSense, it would work. IntelliSense isn't the smartest if you ever used Visual Studios for a while. But now comes the question of, why would you ever use this? You're writing the code, you should know what's going on. Well, I can think of 3 pretty good use cases. If you're going to be doing kernel drivers where you really can't throw an error, because if you throw an error, you're just going to blue screen to death, and no one wants to blue screen to death. Or if you're writing DLL or library code where you can't actually see the source code of it, but you'll be able to have like headers. So say you wrote yourself a static library, you threw it into a file with the header, you took that on a pin drive to wherever you're developing other code, and then you're looking at your code and you're like, what is this supposed to do? I don't remember. I know the basic idea of it, but I'm not exactly sure how it's working. Well, you can add SAL annotation. So you could be like, let's say you have the copy. Well, that's can't use that because it's a template. But let's say we have dump characters, and you're like, oof, can the first one be optional? Well, now you can just see in reads bytes optional. Yeah, you handle it. You're fine. You're good to go. I don't know. A quick little just discussion of this. I think it's pretty interesting because it really helps with like actually coding, and it really states your attention of what it's doing. Like, let me open up a project I got here. Might have some errors. I stopped working on it halfway through. Memory tools. So let's take an example of pattern scan memory region. It's first off, we can see it's a DLL export. That's not SAL though, but we can see the return may be null, so we might be returning null. So we need to handle the case if we don't actually get a pointer from this. Then we can see that we're going to be reading the in-region size from the byte address. Oh, look at that. I actually didn't correctly SAL annotate that. Just simple input, in-region size, and then NZ, so a null terminated string. So what we can infer from this is that we need to handle a null return. We need to make sure that p-base address has at least in-region size of readable memory. We need to ensure that the PSC pattern is of a null terminated string. And actually, I'll just come down here and make sure I fix that for all of these. Let's see here, NZ. Now, it takes a couple tries usually to actually get it proper and everything's annotated proper, because there's a lot of stuff in SAL. You can see this on Microsoft's actual website. You can go through and actually take a look at like all the annotation stuff. They even have like intrinsic stuff, pretty good stuff. There's also the actual SAL source code header, which has a lot of nice comments to actually show you what's going on and how everything's working. Actually, look, I can add null terminated, so I can be like, let's say I were to return a string from a function. Do I actually have that? Guess not, but I could do null terminated, or is this null terminated char pointer get pattern reversed, and then I have a nz const char cz pattern, and then I can also do ret maybe null. Well, I believe that is one thing actually. Yeah, that's one thing. So the return might be null as well. And then what else can I add to it? Oh yeah, ret must inspect result. I think you can also define one. So if we're allocating memory, it is like, hey, you need to free this. But so now what we can infer from this is that get pattern reverse takes in a null terminated string of CZ pattern. We must inspect the results. So we must at least look at the result. I believe that they have one for memory allocation, since we'd probably be allocating a character buffer for this. So you would probably use that instead. Then you'd have it's a null terminated string that you're returning back, and you might get nothing back. And we can also do, I believe, optional here. So you could also say, or maybe the other way, in opt-c. There you go. So now this may be null if, let's say that you pass in a pattern and there's no pass, it's a null pointer. You got it out of some buffer and there's like something missing, and you're handling that condition, and you're now stating to the person who's actually looking at the definition of the function that, hey, this might like not have returned anything, so due to either you're not passing something in because this is optional, or something internally in the function went wrong. So you need to be able to handle these and actually be able to figure out what's going on. And IntelliSense will also give you warnings now of, hey, like, this might not adhere. You might need to take a look at this if it can detect that. So I don't know. I just think if you're doing Windows developing, it's a pretty useful actual. I'm actually going to add this function. That sounds useful. It's a pretty useful thing to add for annotation and stuff. And also, not really related to SAL, but kind of neat, is take a look at this XML stuff. It's actually pretty useful. Like, let's say that I have a function here in a memory tools pattern scan memory region. Where's my annotation? Where's my annotation? Oh no. Okay, well, it doesn't want to load today. But anyways, SAL annotations. Useful stuff. Take a look into it.